Hi, good morning, folks. How are you guys doing tonight? Today. My first mistake, let's start counting them. So my name is Anh Ho. I am a senior engineer at Huawei Technologies. And at OpenDaylight, I function as the release manager for our OpenDaylight project. And on stage is my colleague, Thanh Ha.
Hey, so I'm Tan. I work for the Linux Foundation, and I'm a release engineer on the OpenDaylight project.
And also on stage with us in spirit is our fearless leader, Colin Dixon from Brocade. And he functions as the technical steering committee chair for OpenDaylight. So today we'll be talking about how OpenDaylight manages its simultaneous release. We'll be talking a little bit about the process that goes in to organizing all 54 projects to deliver mostly on time, and the mechanics needed in order to have and to deliver successfully. So let's talk a little bit about the OpenDaylight project itself. It's 3 years old and has already released 5 times. And it's a huge, huge project. It's got 800 committers, 370 in Boron alone. It's got 50 projects, 54 specifically in Boron. And contributions from 120 different organizations and companies. That's a lot of moving parts to manage. And through it all, we're able to deliver roughly on time, give or take. But not always. In the beginning, we were actually about 2 months late. And somehow we've been able to shrink that down. And that comes from tremendous amount of lessons learned, read battle scars, and continuous evolution and refinement to our process. Now, you should care about how OpenDaylight releases our artifacts, because as a developer, you need to understand where and when to insert yourself. But also as end users, you need to understand where it would be best to start producing feedback to projects, and also when it would be best to start testing some of the products that are, some of the project features that are released. So the first thing I want to do is talk about OpenDaylight's simultaneous release framework. Now, the simultaneous release framework isn't the only option that's available. One alternative that we considered was having projects deliver according to their own timeline. So each individual project will release their own artifacts whenever they are ready. And that doesn't work because OpenDaylight moves very rapidly with changing APIs. And we needed a coherent manner with which we can test compatibility across the projects to build a coherent release. The other alternative is to go agile with 2-week sprints. And that process doesn't necessarily work because again, we're working with 120 different organizations, right? How do you coordinate 2-week sprints with all these different companies, all the different engineers who don't respond to the same managers, right? You can't bring a whip to OpenDaylight. So instead, we decided to go with a framework called the Simultaneous Release Framework. And in that framework, we basically release projects every 6 months, give or take. And our releases, our 6-month releases are broken up into 4 stages But the two most critical and important stages are the release development stage and the release candidate stage. In the release development stage, we break it up into what are called milestones. And each milestones represent a logical checkpoint in our release process. The first being who wants to participate, followed by finalizing your release plan, then freezing your features, freezing your APIs and architecture, and freezing your code. And all of these checkpoints exist because we want to make sure that all the 50+ projects communicate their intent, their plan, and their quality to other projects, right? In the release candidate phase, we have a weekly build of the release candidate, and we continuously test and identify any sort of blocking bugs, right? In our release development phase, not all projects follow the same time point for when they send out their status. We have 3 different types of offsets. The first offset, 0, are usually for kernel projects. And whatever they develop tends to be consumed by the protocol projects who are functioning along the offset 1 time frame. And we also have an offset 2 app for mostly applications that are building on top of the protocols and the plugins that are written in the offset 1. And after we release a set of artifacts, we continue to maintain it through what we call stability releases and security releases to ensure that our end users can rely on a certain degree of quality and security patches as they come in. So if you take a look at this diagram, we have 52 weeks in a year. And generally, we want to release twice a year. And in theory, we would have 20 weeks of development followed by 4 weeks of release candidate. But theory and practice isn't always the same. And so what we found is that in practice, there is a set of, it's a little bit more nuanced with holidays that come in. And the fact that there are multiple release trains running at the same time. So in this diagram, you'll see that as Boron is coming to a close, we're still developing Beryllium. And with Boron, we're already starting to discuss and plan and work with Carbon. And so there are multiple release trains all working, all being developed on simultaneously. And that leads into a big key challenge with OpenDaylight, which is how do you release successfully given the complexity that exists with our OpenDaylight project. And I'd like to speak a little bit about those complexities. If you were at the keynote, you'll hear that OpenDaylight is a very dynamic project. It's not a static project. New developers are coming in from different points of view, end users, telcos, vendors, right? And existing developers are leaving or moving to new projects or moving to different focus areas within the same project. And there's a tremendous amount of cross-project dependencies that exist in OpenDaylight. We have 54 projects, and they more or less depend on various other projects. So how do you manage that web of interdependencies? OpenDaylight is also very diverse. like I said, that we have different types of developers, new and old. We have projects that are big and small. We have projects that are more mature, some that are relatively new to open source. So there's definitely problems with trying to manage all of that. And the other thing is scale. How do you scale OpenDaylight as it continues to grow? And so in order to address these key challenges, we have to implement some sort of form of continuous evolution, where we continuously solicit feedback and improve and refine our release process throughout the year. During the developer design forum, but also soliciting feedback throughout the development phase as well. We introduce various improvements to our training, to our tracking, and we also try to act as proactively as possible, addressing issues and concerns before they arise or coordinating cross-project activities before they start becoming big issues. But one of the things that I want to focus on is the scale and the automation. In fact, automation enables OpenDaylight to scale. With every new release, we are seeing more projects, more contributors, and more use cases from our end users, as well as more releases that we need to support. So it is through automation that we are able to scale and grow as a project. And these automation includes automation in building, such as RelEng Builder and RelEng Autorelease, which my colleague Tan will discuss in a couple of minutes. But also automation in testing, like our validation jobs, and reacting proactively to any sort of test failures before they become serious issues. We have automation in our tracking, such as identifying, we have automated scripts to identify dependencies, automated scripts to collect statistics, and automated scripts to help us identify any sort of changes to APIs or Yang files in Garrett. We also have automation scripts in releasing, such as generating our release notes automatically and scripts to help us version bump and tag, which again, my colleague Tan will discuss later. Right? So OpenDaylight, like I said, is a huge, huge project. And in order for it to be the phenomenal success that it is today, a lot of things happen behind the scene. Generally, we have OpenDaylight broken up into 4 distinct phases. And these phases overlap, meaning there's no clear end and start for these phases. The first phase is the release planning phase, the highlight being the DDF, where we work with new projects to identify their, to help draft their release plan for the next release, that being Carbon. But we also help new projects come on board with their new project checklist and help them identify contact information. In the second phase of our release is the release development phase, and that consists of mostly the 5 milestones that I had mentioned before. The release, finalizing your release plan, freezing your features, your API, your code. But throughout the entire process, we also generate these spreadsheets and these matrix to track across all 54 projects where their status is in terms of hitting those milestones. We also track their testing work with a test matrix, an integration matrix. And we also generate a documentation matrix to track where they are in terms of generating their release documents, such as release notes, user guides, developer guides. And we also try to track whether or not projects are fulfilling their release requirements in terms of tests, documentation, and features. The third phase is the release candidate phase, and this is our busiest time of the release, where we actually generate one release each week and ask projects to test and report blocking bugs. And for all the blocking bugs that are generated, we make sure that we follow up. Those blocking bugs are either retargeted or they are fixed, and we make sure that they are verified in the next release. In the next release candidate. Once we get very close to the release, we lock the branch, and any new patches that come in, we conduct what is called a 3D footprint. We analyze the severity, the testing, and the impacts of individual patches to make sure that it doesn't break any dependent projects, and to assess the risk that those new patches coming in will introduce. At the very end, we actually do a go, no-go vote across all the projects. In Boron, we had 54 projects vote go, no-go in 48 to 72 hours, which is amazing considering just how many companies we're working with, just how many developers there are. After a release artifact is published onto the downloads page in OpenDaylight, we continue to support it with stability releases and security releases every 6 to 12 weeks. The requirements for that one is generally we don't ask for new features, but ask for only bug fixes and security fixes to go in. And so these four phases represent the sort of organization that needs to occur throughout the release process. However, mechanically speaking, there are additional work that needs to get done in order for us to release. And so my colleague Thanh Ha will talk about what we do during the actual releasing of artifacts.
Yeah, so I'm going to talk a bit about what the release engineering team does to actually perform a release with the artifacts and build the bits. So one of the first tools we have is a project called the Autorelease Project, which it's a very simple project. It's essentially just an aggregator project of all the projects participating in a release. So, and it has a few bash scripts that we use to automate a few of the tasks. So if you clone the Autorelease project, it actually clones all of the participating projects for whatever branch you're cloning as submodules. And in essence, if you clone Autorelease, you can get the source code for every project that's participating in a particular release in the same repo. And the biggest thing probably is the superprom in the Autorelease project, which is used to build all of OpenDaylight using a single Maven call. Boron takes about 8.5 hours-ish to build. So if you cloned Autorelease and ran a Maven clean install, it should take you about 8.5 hours. And it also deploys, at the end of the build, it deploys all the artifacts to a staging repo in Nexus, which we can use to test and make sure the release is good. And in theory, if it turns out to be good, that is what we actually publish to a release repo later on. And the build actually is built at midnight on UTC time every single day. And it actually produces basically a release quality build every night. So in theory, if the TSC decided, they could pick any particular build on any particular night to release. But in practice, we run more integration tests, et cetera, before we do any sort of releasing. The Autorelease build also produces what's called a Git bundle for every single project. And we're able to use that to construct a byte equivalent commit as what is built by the Autorelease project during its build. So we use that later on when we're actually releasing to ensure that we're releasing exactly the same Git commit that was used by Jenkins to produced the release, and we also tag that as well. And we also generate a taglist.log file, which we use to validate and make sure that whatever Jenkins produced is actually what we're pushing. Another thing we do is, as the release approaches, at the end of what we call milestone 5, and just before we start producing our release candidates, we branch stable release branches, which essentially at that point, the only code that should go into the stable release branches are bug fixes and whatever is like the wrap-up kind of code to get our final release going out. And we also version bump our master branch by 0.1.0 to enable any developers who want to start working on the next release while we have feature freeze on our current release branch. Yeah, and finally on release day, we release our simultaneous release. And what's involved there is the release engineering team will use our GPG keys to sign all of the artifacts. And it produces a second staging repo in Nexus. And then we release both staging repos that contain the binaries as well as the signed artifacts into our Nexus release repository. And again, we use the Git bundles to regenerate the commits, and we push those commits to Garrett as well. And we tag the release for all the projects. And finally, we also version bump by 0.1 on the stable release branch, which allows us, or sets us up for the next service release a couple weeks down the road. And I also want to highlight that there's a couple artifacts that we especially highlight on the downloads page. While all the artifacts go to Nexus, on the downloads page, we make it clear that you can download the craft distribution, which is what most end users will probably be downloading. But also like VTN Coordinator, NextUI, and Upflex, they have their own binaries that if you use those components, you'll need additionally. And in Boron, we also have a new project, Yang IDE, which is actually an Eclipse project. And they produce what's called an Eclipse P2 repository, which you can take the URL for that and paste it into your Eclipse install to download the latest Yang IDE. And I actually think it's also available in the Eclipse Marketplace, so you can go to the Marketplace and just search for it as well. Yeah, and pass it back to Anne.
Yep, thanks, Tan. So as I was talking about the continuous evolution aspect of OpenDaylight, we continue to solicit feedback and try to improve and refine our release process. So what does the future of OpenDaylight has on its door in terms of release management, release engineering? Well, we're currently in talks to introduce ideas such as semantic versioning, better test incentives, more frequent releases, stage snapshots. We're looking to implement some sort of peer review process for release documents, and also to use gamification to incentivize our projects to follow the suggested release plan, as well as providing some sort of project grouping so that we can have better and stronger social support network across the projects. But the key takeaway from this presentation is that OpenDaylight is a huge, huge project, and somehow we have been able to deliver mostly on time across all the 54 projects, 120 different companies, and 800 plus developers. And what we really need is folks like you to come in and help contribute and to help us improve our release process. I think we're out of time, so we'll take questions outside the hallway. And thank you so much for all folks for joining us today.